The habitable zone is the region around a star where an orbiting planet could host liquid water and therefore possibly support life. The habitable zone is also known as the Goldilocks Zone because planets orbiting at the just right distance from a star are not too hot or too cold to host liquid water. If planets are closer to their star, the water turns to steam, and if farther, it freezes. Some researchers think the potential for liquid water has too simplified a picture of what it takes to support life. Venus, for example, is technically in the Sun's habitable zone, as its orbit keeps the planet within the area where liquid water could possibly exist. But in reality, the planet's carbon dioxide-rich atmosphere gives it the hottest surface temperatures of any planet in the solar system, and it's unlikely that life exists on its scorching surface or in its skies. The Goldilocks zone is different around each star. Bigger, hotter stars like the Sun, a G-type star, have wider habitable zones, whereas smaller red dwarfs confine habitable planets to a narrower range, according to NASA. But G-type stars are shorter lived, on a galaxy timescale that is, than other types of stars. One abundant kind of star, K-type stars, can burn for tens of billions of years, and because of their stability, might have the most promising habitable zones. But stars are individuals too. For example, some red dwarfs are unpredictable, sending sterilizing flares towards their planets, while others are steady and reliably calm. So while two stars may have similar habitable zones and similarly sized planets, one star system might contain a much more promising candidate for life. One example is the exoplanet TOI 700d, discovered by NASA's Transiting Exoplanet Survey satellite TESS in 2020. The star that TOI 700d orbits could have been considered an unlikely home for life-bearing planets, based on its type and its habitable zone alone. However, it's a particularly quiet star, and has been stable long enough that on one of its planets life could indeed exist. A star's habitable zone does not depend on the types of planets that are in the region. Gas giants are less likely to harbour life, so in addition to searching for planets in stars' habitable zones, researchers look for worlds that resemble Earth in atmosphere and size, along with chemical composition. The Goldilocks Zone is a reference to the fairy tale Goldilocks and the Three Bears. In that story, Goldilocks discovers two extremes and then locates things that are just right for her. Similarly, planets too close to their star are too hot and those too far away are too cold, whereas those in the Goldilocks Zone are just right. Just right, in this case, is distances from a star that could allow stable liquid water on a planet's surface. In our solar system, the Earth is clearly in the Goldilocks zone, with much of its surface covered by liquid water. Venus is too hot, Mars too cold, but the Earth is just right. Since the Goldilocks zone is based on theoretical modelling and certain assumptions, some definitions may barely include Venus's orbit or Mars's orbit if the models yield planets different than Venus or Mars that could potentially have liquid water on the surface. Size depends on the type of star and the theoretical assumptions that are used to determine whether liquid water might be stable on the surface of a planet. For our solar system, there are various definitions. So to take an example where Venus's orbit defines the inner boundary and Mars's orbit the outer boundary, the total width is approximately 120 million kilometers. In the case of our solar system, Venus, Earth and Mars all orbit within the Sun's habitable zone. Venus is just far enough away from the Sun for the planet to have the possibility of hosting liquid water, but its runaway greenhouse atmosphere makes the planet even hotter than Mercury, even though Mercury is much closer to the Sun. Venus's atmosphere effectively eliminates the possibility of life as we know it on the planet's surface. Earth is directly in the middle of Sun's habitable zone, which is likely no coincidence given that we created the idea of habitable zones to search for planets like ours. To be honest, we have only one frame of reference, but as a result, we may be overlooking even better conditions for life than those on Earth because our view may be too narrow. Mars is at the far chilly edge of the Sun's habitable zone. But there is evidence that an ocean may once have flowed on Mars, and NASA's Perseverance rover is still sampling for microbial life that could be hidden below the planet's surface. Researchers use the idea of a habitable zone to narrow down which exoplanets might be good candidates in the search for extraterrestrial life. In 2023, NASA's Kepler Space Telescope and test missions detected and catalogued more than 5,000 exoplanets, according to NASA Exoplanet Archive, and those represent just a tiny fraction of the planets we're likely to discover as we keep looking. Kepler showed that, on average, every star has at least one planet.